Hey guys, so in this video, I will hopefully be doing questions 7 to 17. So here, whenever you see limit as x approaches a minus, and a is any number of a function fx, then this means that it's a left side limit because of the minus. And what that means is that it's approaching a from the left side. And when you see limit as x approaches a plus of fx, and fx is also any function, um, because there's a plus, it's called a right side limit. And what it means, it's approaching a from the right side. Now, if the limit as x approaches a minus of fx is equal to c, and the limit of as x approaches a plus of fx is equal to c, then the limit as x approaches a is also equal to c. So basically, if the left side limit and the right side limit, both of them exist and are equal to the same number, then the limit at that point is also exists and is equal to the same number as well. So in grid question number 7, they gave you this, and they said for what value of k does the limit as x approaches minus 3 of fx exist? So now we said when the limit as x approaches minus 3 of fx, it exists when its left side limit and its right side limit are equal. So now that you wrote this, we need to find what's this and what's this. So the limit as x approaches minus 3 from the left side is here. So we're getting very close to minus 3, but we're a little bit smaller than it. So that's why we use the equation with the condition as if x is smaller than minus 3. So we put this here. And for this one, it's as x approaches minus 3 from the as x approaches minus 3 plus. So it's from the right side. So we're very close to minus 3, but we're a little bit greater than minus 3. So we're going to use this equation because x is greater than minus 3. So you put 4x squared here. And then what are we going to substitute for x? We're going to substitute minus 3 because that's the number we're looking at right now. So if you substitute minus 3, you're going to get k equals to 39. And that's your final answer. So for grid question number 8, they gave you this diagram and they gave you options, and you need to choose which ones are true. So let's start with the first one. The limit as x approaches 0 minus of fx equals to 8. Let's see. If it's approaching 0 minus, then it's approaching 0 from the left side. And here we can see that as it's going to 0, it's going to 8. So that's correct. The second one, they said limit as x approaches 0 of fx equals to 6. In order to see the limit as x approaches 0, we need to see as x approaches 0 minus and as x approaches 0 plus. If both of them are the same number, then that would be that number would be the answer here. So we know what's as x approaches 0, it's 8. Let's see as x approaches 0 plus. If you look here, when we're approaching 0 from the right side, it's going to 4. So 4 and 8 are not the same, so it doesn't exist. So this is wrong. The third one, they said the limit as x approaches 0 plus of x. And we said it's approaching 0 from the right side, it goes to 4. So that's correct. And the last one, and number 4, they said as x approaches 0 of fx does not exist. And we said it doesn't exist because as it approaches 0 minus, it's not the same as when it approaches 0 plus. So this one is right. And these two are wrong because we already found what's x approaches 0 minus and what's x approaches 0 plus. So it's only 1, 3, and 4. Let me just write it down. So now let's talk about limit as x approaches infinity. So the first thing you do when they give you a limit as x approaches infinity is you would pick the number with the highest power of x in the numerator and a number that has the highest power of x in the denominator. So for example, if they give you this limit, you would pick 2x squared in the numerator because it has the highest power, and you'd pick 4x cubed in the denominator because it has the highest power in the denominator. So after this, if the power in the numerator is greater than the power in the denominator, the answer will be infinity. If that power in the numerator is equal to the power in the denominator, the answer will be 1. And if the power in the numerator is less than the power of the denominator, the answer will be 0. Sorry, I made a mistake. If the power in the numerator is equal to the power in the denominator, then the answer will be the ratio of the coefficients. So here to be a over b. So what is the explanation for those rules that we just took? So let's say the power in the numerator is greater than the power in the denominator, for example 4x squared over 3x. First of all, the x would cancel and you'd be left over with limit as x approaches infinity of 4x over 3. Now, as x approaches infinity, x is getting bigger and bigger and bigger. And this makes this whole thing become bigger and bigger. So therefore, the answer will become infinity because this just keeps on getting bigger until infinity. Now here, when the power in the numerator is equal to the power in the denominator, the x's would cancel, and therefore you will be left over with limit as x approaches infinity of 4 over 3. And we know the limit of a constant is that same constant, so it would be 4 over 3. Now, if the power in the numerator is less than the power in the denominator, first of all, the x's would cancel, and you'd be left over with limit as x approaches infinity of 4 over 3x. Now, when x is getting bigger and bigger, you're dividing 4 by a bigger and bigger number. So this whole thing is becoming smaller and smaller and smaller until it becomes very small, where it's very close to 0. So the answer is 0. And that's why those rules that we took make sense. So in question number 9, they're asking which ones are correct. And these are all limit as x approaches to infinity. So let's look at the first one. The highest power in the numerator is 3x squared, and the highest power in the denominator is x squared. So these two would cancel, and the answer would be 3. So this is correct. Here, the highest power in the numerator is 2x cubed, and the highest power in the denominator is 3x squared. So this would cancel with this, and anyway, the power up is greater than the power down, so the answer is infinity. So this is correct. Here, the highest power up is negative x to the power of 5, and the highest power down is x cubed. So in reality, if you actually solve this, it's going to be negative x squared over 2. Now we took that if the power up is greater than the power down, it's going to be infinity. But here you can see as x goes to infinity, the answer actually goes to minus infinity because there's a negative here. But I don't think they're going to trick you with this in the exam, because anyways the answer here is wrong. It should be negative infinity, and here they put 0, so the answer is wrong. So I don't think you need to worry about that. Now here, the highest power in the numerator is 5x squared, and the highest power in the denominator is 3x squared, so these would cancel, and the answer is 5 over 3. They put 6 over 7, so that's wrong. Here, the highest power is x to the power of 6, and the highest power down is x to the power of 7. So the power in the numerator is less than the power in the denominator, so the answer is 0. So this is right. And here, the highest power up is 4x squared, highest power down is 8x cubed, so the power in the numerator is less than the power in the denominator, so the answer should be 0, and here it's wrong. So the correct answer here is 1, 2, and 5. So in grid question number 10, they said fx is defined for x greater than or equal to 1, gx is defined for x smaller than 1, limit as x approaches 1 minus of gx exists, and then they give you these. This given and this given are the most important given out of this whole question. They said limit as x approaches 1 of hx exists. If that exists, then what is the limit as x approaches 1 minus of gx? So first of all, they said this exists, and if we know that this exists, then its left side limit and its right side limit should be equal. Okay, that's how it would exist. So you'd write the left side limit equal to the right side limit. Now, the limit as x approaches 1 minus of hx means we're approaching 1 from the left side, which means we're very close to 1, but we're smaller than 1. So we would use this one because it says when x is smaller than 1. So we would use limit as x approaches 1 minus of gx. And why 1 minus? Because it's the same thing here. Now, limit as x approaches 1 plus of hx, we would be approaching 1 from the right side, so it would be a little bit greater than 1. So we would use this one because it says when x is greater than 1. So we would use limit as x approaches 1 plus of fx. Now, they're asking for limit as x approaches 1 minus of gx. So we have this here. So if we can find limit as x approaches 1 plus of fx, we'll find this. So the way we find this is we look at the diagram. If we're approaching x, if x is approaching 1 plus, then we're approaching 1 from the right side. And if we approach 1 from the right side, then we get to 4. So the answer would be 4. So now let's talk about continuity. For a function to be continuous at x equal to a, the limit as x approaches a minus of fx should be equal to the limit as x approaches a plus of fx, and that these all should be equal to fa. And this could be written as limit as x approaches a of fx is equal to fa, because if these two exist and are equal, then this also exists and is equal to these two. Now, if only this is equals to fa, then it would be called left continuous, because only the left side limit is equal to this. And if only this is equals to fa, then it would be called right continuous, because only the right side limit is equal to fa. And that's it for continuity. So in question 11, they give you this big thing, and they're asking which ones are true. So the first one is limit as x approaches minus 2 minus fx equals to f at minus 2. So let's see, as x approaches minus 2 minus, it means it's approaching minus 2 from the left side, so it's a little bit less than minus 2. So we would use this one because x is less than minus 2. So it would be, we would use x plus 1. And for this one, f at minus 2, so x equals to minus 2. So we would also use this one. So if you substitute minus 2, because that's the number we're looking at right now, minus 2 plus 1 equals to minus 2 plus 1, you get minus 1 equals to minus 1. So they're equal, so the first one is correct. The second one, as x approaches minus 2 plus of fx, it's approaching minus 2 from the right side, so it's a little bit greater than minus 2. So we would use this one, not this one, because it's just a little bit greater than minus 2. So we would use x plus 2. And f at minus 2, we already found it to be minus 1. So let's substitute minus 2 here, and you would get 0 equals to minus 1, and that's false. So number 2 is wrong. fx is right continuous at x equal to minus 2. If it's right continuous at x equal to minus 2, then the limit as x approaches minus 2 plus should be equals to f at minus 2. And we found that that's not the case here, so this one is wrong. fx is left continuous at x equal to minus 2. That's correct, because we found that as x approaches minus 2 minus, it's equal to f at minus 2. So 4 is correct. Now they're asking fx is continuous at x equal to 2. If it's continuous at x equal to 2, then it has to be, then the left side limit should be equal to the right side limit at x equal to 2. Left side limit would be as x approaches 2 minus, so a little bit less than 2. So we're approaching 2 from the left side, so it's a little bit less than 2. So we use this one because it's a little bit less than 2. So it's x plus 2. We use this equation. And so this is the left side limit. If you substitute 2 here, 2 plus 2 equals to 4. Now that's for the left side limit. If it's continuous, then it should be equal to the right side limit, and it should be equal to f at 2. So let's look at the right side limit. Right side limit, so we're approaching 2 from the right side, so we're a little bit greater than 2. So we'll use this equation. So 2x, substitute 2, you'll get 4. Now f at 2 will be x equal to 2. So we'll also use this equation. So 2x, the same calculation, so it's also equal to 4. So because all these are equal, then it is continuous at x equal to 2. And here it says it's not continuous at x equal to 2, but that's wrong because we just proved that it is. So the correct answers are 1, 4, and 5. That's it for this video because the video is getting too long. So I'm going to do the rest of the questions in the next video. Bye.